Good day everybody, we got an interesting question. So foremost I will have to draw the quarter circle. So let me draw that. Okay, so you have a quarter circle inside a square. So let me name it as A, B, C and D. Now the next important thing is we've been given the diagonal. So this is the diagonal of the square. So AC is the diagonal. Now this is a unit circle. ABCD is a unit, I should say unit square. And that would mean side is equal to 1 unit. So that is the side. So each side is 1 unit for this particular square, and you have a quarter circle inside this. Now the diagram does not stop there. Okay, so I've got a circle inside the quarter circle. So this is the circle inside, and the circle is touching. There is a point of contact with the quarter circle over here. There's a point of contact over here with the diagonal, and there is a point of contact here. So figure is not to scale. I've tried my best to squeeze the circle inside the semi, or I would say inside the quarter circle. So this is the figure. Now what are you expected to do? You have to find the area of the shaded region of. Now which area are we talking about? We are talking about this area, this region, this region, this region. We have to obtain that area. Now we are not given the radius of the circle. This circle, say, let me take this as, say, C1. We are not given this radii. We have to find that. All we are given is the side of the square is 1 unit. You can pause the video and you can try this question, and you can come back and see the solution. Okay, I hope you have got the solution. Let me show you how to get the solution. So foremost, what I'm going to do is I'm going to take the following. So let R be the radius of the circle C1. That is the first point that I would like to assume here. So now what I'm going to do is, through this, from the vertex, I would like to draw a line that passes through C1. I can very well do that. So let me do that. So okay, that's a line. It originates from A, it goes up till this point on the quarter circle. Now if you see the quarter circle, let me take the quarter circle to be as C2. The quarter circle has a radius of, what do you think is the radius of the quarter circle? Now the side of the square is 1 unit, and the quarter circle has a point of contact with the side of the square. Now this is the center of the quarter circle. So clearly the radius of the quarter circle is also going to be 1 unit. That is a very important observation. So that would mean from here to there, from point A to, if I were to take this to be as point E, this means AE is equal to 1 unit. Now AE is 1 unit, fine. Now what I wish to do next is drop a perpendicular from C1, I'm taking C1 to be the center, to AB. Now there is a point of tangency here, so that would mean this perpendicular which we are dropping is going to be making an angle of 90 degree. This is a most popular theorem, the theorem involving the tangent to the circle. Okay, so this in turn would mean I need to know what is AC1. Now AE is 1 unit and I've taken the radius of the circle, radius of this small circle to be as R. So this would mean this is R. So this means AC1 is equal to, from here to there, from AE is 1 unit. So from 1 you take away R. So this is going to be 1 negative R. Fine. Now let me take this point to be as some F. Now clearly I see that I have a right triangle. On observation, what do you see? Triangle AFC1 is a right triangle, right? So that will mean I can apply Pythagoras. So let me take this distance AF to be equal to some x. Let AF be equal to some x. So this would mean by Pythagoras theorem we get, so what do we get by Pythagoras theorem? AF squared plus C1 F squared is equal to A C1 squared. Now AC1 squared is 1 negative R raised to the power of 2. C1F, this is going to be R squared. AF squared, I have taken AF to be equal to some x. So this is going to be x squared. So let me get the value of x squared. So x squared is equal to, I expand this, I get 1 positive R squared, negative 2 times R, negative R squared. This goes cancelled off. So you get 1 negative 2 times R is equal to x squared. So therefore x is equal to root of 1 negative 2 times R. So I've got the value of this, square root of 1 negative 2 times R. Okay. Now AC is the diagonal. You see that AC is the diagonal. Now this entire angle is 90 degree. So if AC is a diagonal, it would mean 90 degree would be split into 2 parts. So 90 degree is pi over 2. That is going to be split into pi over 4 and pi over 4. So this entire angle is going to be pi over 4. Let me write this. This is pi over 4. This entire angle is pi over 4. Okay, fair enough. Let's just have that in mind. This is to draw your attention. Okay. Now you see this C1 is the center and there is a point of tangency. Let me connect that. So I'm going to connect this point of tangency with C1. So if I were to do that, this is going to be making an angle of 90 degree. So I've got EFG. Let me take this point as G. So AC1G, clearly I'm writing down here, clearly AC1G is congruent to AC1F, isn't it not? You have a common bisector and this side is equal to this side. What else we need? So that would in turn infer that this bisector which you see here, this is going to be an angle bisector. So that angle bisector would be dividing this by into two parts, right? So this is already pi over 4. So this is pi over 8. This is pi over 8. So that is the observation I want to draw your attention to. Okay. So having got that, we move on. So what are we to do now? We will consider triangle AFC1. So I'm going to consider this triangle AFC1. So the triangle looks like this. This is pi over 8. This is A, this is F, and this is C1. This length is R. This length is 1 negative 2 times R. And this length is 1 negative R. Now what I wish to do is I would like to take tan theta. Tan theta is opposite side by adjacent side. Over here, tan theta is R divided by root of 1 negative 2R. Now why am I doing this? I want to get the value of R. Simple as that. Now theta is taken to be as tan, the value of theta is pi over 8. So tan pi over 8 is equal to R divided by root of 1 negative 2R. So this is what I've got. Now the question is, I will have to get the value of this R. So let me do that. So we need to simplify this. Now we know that tan pi over 8 is root of 2 negative 1. Now this is the all important value that we will be utilizing. We have got this tan pi over 8 is equal to R over root of 1 negative 2R, and as I mentioned to you, tan pi over 8 is equal to root of 2 negative 1. You substitute that, you get root of 2 negative 1 is equal to R over root of 1 negative 2R. This is what you got. And now what I'm going to do, I'm going to square both sides. So if you were to square both sides, I would get root of 2 squared negative 2 times root of 2 positive 1 is equal to R squared divided by 1 negative 2R. And you simplify this. This is root of 2 squared, so it's going to be 2 negative 2 times root 2 positive 1 is equal to R squared divided by 1 negative 2R. Now you add these two, you get 3 negative 2 times root 2 is equal to R squared divided by 1 negative 2R. You cross multiply, you get 3 negative 2 times root 2 times 1 negative 2R is equal to R squared. You distribute it, you get 3 negative 6R negative 2 times 2 and positive 4R times root 2. 2 to the 4 and you have root 2 and R is equal to R squared. Now what I wish to do is I would like to club these two together and these two together. So this is 3 negative 2 times root 2, and over here I would like to take R out. So I will take 2 out, R out, and I'll take a positive sign. So this is going to be 2 times of root 2 negative 3. So 2 times 3 is 6 and you got a R there, negative sign, so this is fair enough. This is equal to R squared. Now bring everything to the right hand side. So that's going to be R squared negative of 2 times R, 2 times root 2 negative 3, negative of 3 negative 2 times 2 is equal to 0. Now this is a quadratic in R. So R is equal to negative b plus or minus root of b squared negative 4ac divided by 2a. This is the formula I would be applying. So this is equal to This is 2 times r of 2 times 2 negative 3. Because negative and negative, they get neutralized. So plus or minus root of, this is going to be 2 times of, no, we don't need to give an r here because it's a quadratic in r, so take that out. So this is going to be negative of 2 times root 2 negative 3. You take the square of this, negative 4 times a is 1, and you have a negative sign in c, so this is going to be plus. So this is 3 negative 2 times root 2 divided by 2 times a is 1. So this is equal to 2 times of 2 root 2 negative 3 plus or minus. We have to simplify this. So you take the square here, this is going to be 4, and square of this is going to be 2 times root 2 squared plus 3 squared 9 negative 2 times 2 4, 4 times 3 12 times root 2. So this is going to be positive 4 times 3 is 12 negative 8 times root 2 divided by 2. So this is equal to 2 times of 2 root 2 negative 3 plus or minus root of 2 squared is 4. This is 2. 4 times 2 is 8. 8 times 4 is 32, right? 4 and 8, 32, plus 9 4s are 36, and then you got a 48 root 2 plus 12 negative 8 times root 2 divided by 2. So these things can be added. So 32, 32, 62, 68, 70 and 80. That's going to be 80 there. 80 and 8 and root 2. So I can take an 8 out. So if I take a 8 out, this is going to give me, in fact I can take 8 and I can take root 2 out. So this is going to give me 6. 6 8s are 48, negative sign, and another negative sign, right? 6 8s are 48. In fact, I can very well add these two quantities, isn't it? 6 8s are 48, negative, this is going to be positive, and then I get 1. So this is how it looks. So 8 times 6, 48, negative 48, right? And negative 8 times 1, that's going to be, I would say, you get negative 8 times root 2 over here. So this is going to be 7. So you could have directly added that. So alright, so this is under the square root, and you have 2 times of 2 root 2 negative 3 divided by 2. This is plus or minus. Okay, so you have this value. Now what I wish to do is I want to take can I take a square root 56? So let me rewrite this. I want to rewrite that. So this is equal to 2 times of 2 root 2 negative 3 plus or minus root of 80 negative 56 times root 2 divided by 2. Now if I were to take 8, that's the only thing I can do, right? So if 8 is taken out from here, this would give me 10 negative 7 times root 2. That's the best we can do in this case. And you apply the square root, you have plus or minus, you got 2 times of 2 root 2 negative 3 divided by 2. So 4 times 2, so this is going to be 2 times, I'm going to write it as root 2 times root of 10 negative 7 times root 2, right? 8 is 4 root 2 or root of 4 times 2. So that's going to give me 2 times root of 2. So that's the value that I have got here. So plus or minus, this is going to give me 2 times of 2 root 2 negative 3 divided by 2. So all of these values will result in producing the value of R, but I need only positive value. So I'm going to take R to be as only positive. So this is going to be 2 squared of root 2 negative 6 plus or minus 2 times the root 2 root of 10 negative 7 times the root 2. I don't need to take that negative sign, divided by 2. So I can club these two together. So this is going to be 2 times root 2. I'm clubbing these two together. And if I were to do that, I would get 2 here. And then plus root of 10 negative 7 times the root 2. Right? And that is fine, followed by a negative 6 divided by 2. So this is the value of R. Now we need to simplify and get the value of R. So for that we need the calculator. So before simplification, I can actually reduce the 2's here. So this will become 3, this is goes up. So you have a value root of 2 plus root of 10 negative 7 times root 2 followed by negative 3. So this is the value of R. So we need to evaluate this and get the value of R. Now this is the value of R. You can check it out, and this is the exact value that you will get. So I would go on to evaluate this value. So foremost I will evaluate this. So this is going to be 7 times root 2. So root 2, if you were to take the value of root 2, that's 1.414, right? 1.414 multiplied with 7, that is going to give me 9.899. So this is going to be root of this value. So you have a negative 3 there. So positive 2, and then you have a product of root of 2. So now 10 negative 9.899, what is that? This is giving me root of 0.101 and negative 3. So this is equal to, I'm going to take the square root of 0.101. Okay, that is giving me 2 plus 0.3178 negative 3. So I added 2 there. So this is going to be 2.3178, and I multiply it with root of 2. So 2.3178 multiplied with root of 2. And okay, that is giving me 3.27786. You subtract 3 from that, so approximately 0.27786. I'm going to take it as 0.278, or I will take it as 0.28. That will be the value of R. So R is taken to be as 0.28. You can check this out and you will get the same solution. Now this would mean the area of the circle that we were talking about is pi into R squared. So that's going to be pi times of 2.8, the 0. Pi times of 0.28 squared. So 0.28 squared, that is giving me pi times of 0.0784. So I'm going to keep it like that. I'm not going to do any evaluation for this area of the circle. So that is fair enough. Now what I'm going to do is I would have to calculate the sector area. So area of the circle is calculated, sector area. Now I'm going to take it as A, B, C, D, E, F, G, H. So I want to calculate this area of this sector. Now, as I mentioned to you, this is the diagonal. The diagonal is splitting the square into two parts. So pi over 4 and pi over 4. So theta is pi over 4. And we have got the radius. The radius is 1 unit. So we will get the area of the sector. So now I'm going to calculate the area. Sector area is theta divided by 360 times pi into r squared. My theta is 45 degrees divided by 360. My radius is 1 unit. So this is going to be 45. 9 5s are 45. 9, 4 and 5 here 8. So I got pi over 8. This is the area of the sector. Area or sector area. So required, now as I mentioned to you, I am looking to find the shaded region, right? So from required area is from the sector area, I will take away the area of the circle, right? So sector area is pi over 8 and circle area is pi times 0.0784. So this is equal to pi is taken out. So 1 over 8 minus 0.0784. So this is equal to 1 divided by 8. That's 1 divided by 8 is 0.125 minus 0.0784. So that gives me a value of pi times of 0.0466. Right, this is the value that I'm getting when I subtract. So this can be approximately taken to be as pi times of, now let me rewrite it like this. So this is equal to 0.047 pi square units. So that is the area of the shaded region. Now this is a very interesting question, and we have successfully got the result. So you can go through this result, analyze it, and give your insights. And until we meet again, enjoy your day. Thank you.